Okay, so it's running farther now. Let's see, it's currently resolving probably the first plus, right? Oh, it's resolving a pair enclosed. Alright, no problem. That still seems okay. How many leaves are there? There's 2 leaves, a 3 and a 5. Now what do we got? There's still 2 leaves, an 8 and 11. Those are getting multiplied together now. Let's walk through that because that's just fun to watch. 2 leaves, right? Okay, so it's going to pull. The type of operator is multiply, 2 operands. It's going to fill this up with the 8 and the 11. Good. And then it does a multiply, which between those two things result in an 88. Perfect. And then the count has dropped down to 0, but then we put a new one in. So the count is 88, or the value is 88, and the leaf count goes to 1. Very cool. Yeah, Slash Life just asked me if I have a ceiling fan, and the answer is I do, but that's not what you hear, because I'm hearing what you hear. My ceiling fan's always been going on all my streams, and I haven't had that sound going on. It sounds more like I have central air on right now, which I don't know why that's going on, because that doesn't normally come on quite that loud. Okay, next. So now the leaf count is 3, interestingly. We have an 88, a 90, and a 2. So it hasn't decided to resolve the equals yet. First it's resolving the 90 minus 2, because that's stickier than equals. It can't resolve 88 equals 90 and then subtract 2 to get, that's not what we want. First it's resolving 90 minus 2. So the result it just got is 88, puts it there. Next time through, now it's got 2 88s. It's going to see that its type is not equal. Cool. Man, this is, I love languages. Yeah, the flickering in the picture behind me is a ceiling fan. Exactly. Correct. Alright, so not equals, and this is not equal. That is false, so we put a 0 there. And then that should be it. That should put a leaf of 0 there, and we're done. It's probably going to try to resolve. No, it doesn't got anything to resolve. Oh, I never actually set the failed variable after all that. So 1268. So we do all the parsing and then just discard that information and assume we fail. Perfect. Sounds like alright, failed equals, so if you put a 0 there, you want to say, okay, this is kind of confusing. You did fail if there was a 0 there. So basically if leaves, and also if you've properly finished parsing, the number of leaves should always be 1. Failed equals, and that's one of those ones where maybe not true if error occurred, but if I say tentative there, that would tell me that I meant to handle the case where there wasn't one, and I don't. You should always have 1 if you've correctly finished parsing. So leaves.leaves equals 0. Alright, running that. Let's see if we can mess with these breakpoints a little bit. This one we can delete. That keep, delete. don't edit the code. Okay, there we go. Failed equals true, so it does that work. Comes to the end, and we have success. Now, since I just realized I wasn't even messing with the variable, whether we have success or not was kind of dependent on whether success was a pass or a fail. So let's make this thing work now. Parse easy. Okay, parser test2.cpp. Now we're going to give this a little bit of a workout. Might help if I rebuild. Alright, so we do have errors. 2 leaves. What do we got? 0 and 0. Interesting. This could easily be because we're on one with defined or something. Okay, so what I'm going to do is say for now, the defined operator always results in false, just to make sure we're not doing anything that creates problems. I don't think we could be, but okay. I don't think that fixes anything. There's no reason that it should. Good. That means that's not crazy. So my question now is, what are the local tokens looking like? How many of them are there? There's 4. So that means the relevant ones are the first 4. Identifier, parenthesis open, identifier, parenthesis close. Is that so? '53, '54, '50. They're all straight in on a row. I wonder what position is that? Is at 476. So let's take a look at what that means. So I want a copy of this token down here. I want a copy of his file index. I want a copy of his start position. Okay. Then what I want is definitions, files, plus 0. What do I get? Yes, I want you. I want you. And I want to add 476. Okay, so it's taking defined as an identifier. Okay, so let's look at it. That means that what I did on the Lexer at the beginning didn't stick. It didn't do what it was supposed to do. Let me take a quick peek at the test case too. Data test 2 defined right there. That's where it starts. So yeah, this is after an if. And I'm saying if I'm in an if body, whoops, this is the Lexer test, which is the file with the parser in it. I wanted Parser, which is the file with the Lexer in it. So /life is asking about uh, how you improve over text for representing code. And I'll just comment real quick because, uh, for one thing, if you think about like art, the simple way to represent art is colored pixels, but uh, all it takes is a little bit of thinking, and over time you come up with like better ways, layers and blend modes and things. It's not about changing the primitive structure of what you're building. It's about changing what the tools provide for you. Now, with code, the problem is that people just aren't looking at what are the higher level things. And one of the very simple things that's a higher level thing in the language of C and C++, and this is very language specific, the kinds of things I'm looking at. But there's the idea of compilation units. And Visual Studio kind of tries to help you organize the compilation units, but it does it in a really dumb way where it just says include a CPP file, and that's a compilation unit. And then there's a problem of a certain file can be included multiple times in separate compilation units or in the same compilation unit with different results from that file, like depending on the circumstances it was included in. So there's an idea of a file being viewed from multiple points of view. And then once you get down to, once you get past that kind of stuff, there's ideas of like the abstract syntax tree of your code, right? So once you parse code, you have it in the form of an abstract syntax tree, which is a different way, which is what compilers do. It's a different way of internally representing the idea of code, and so you can do things like, reconfigure local variables into a struct very easily. You can pull code out into a function which exists in places, but also, like if you want to do things like blowing out one function into multiple functions that don't have what's the word I'm looking for? Default arguments, if you prefer not to have default arguments for some reason, or something like that. There's all sorts of things where you can take advantage of the structure of the code to have higher level editing modes. Not to mention just opening up the abstract syntax tree and viewing it as a tree can sometimes be useful. Okay, so anyway, what I was dealing with was yes, body if pp state, pp up default mode. Alright, so that is my problem. I did not pass a 1 there. Problem solved. Uh-oh, more errors. Alright, what are we trying to resolve here? What's the type that we've got? 13. What type is 13? pp expression op type 13. Bitnot. Okay. Oh, could that be it? operand count 2. Bitnot has the wrong operand count. Wrong file. What? Okay. Let's try this again. It was not the bitnot that it was trying to resolve, it was something else. Bit and. Okay, so I want to take a look at which one has a bit and a bitnot and put that in the easy debug file. Test 2. There we go. Easy debug. Define other thing 3. Alright, now I want to Lex test. Instead of test 2, I want easy debug 1. Okay, so we're still breaking, which is good because it means that it shut down properly and it really is just a problem with this individual thing. So, I'd like to break, I'll break right here, see if that gives me any information. Leaves, 1, ops, 2, that does not give me any information. Let's back up just a bit. Wait, let me get the spot again. There we go. Up, 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 up. Okay, right there's a good breakpoint. Because that will let me see the token stack, make sure that looks good. How many are there? 8. 8 tokens to parse. Parenthesis open, integer constant, ampersand, tilde, integer constant, equals equals, integer constant, parenthesis close. I already think I know what's happening, but we will go through it. Alright, let's see. Open parenthesis. Not a problem. Constant. Not a problem. You can't resolve that before you resolve that. It's left hand. That's right associative. It's like right associative unary operators need to be, so bitnot needs to have a higher precedent is the problem. Okay. Okay, bit not. Just going up here under not. Bit not. Just going up here under not. Okay. Okay. I'm gonna watch ops and leaves real quick. So then we push a second op on that. That's the tilde. Then we push a third op. What just happened? The tilde didn't resolve right away, did it? What's the third op? What's it doing? Easy debug. It shouldn't have resolved by doing this one. Okay. I need to walk through that part. How many ops do I have? I have one for the parenthesis. I have an identifier. I have, oh, there's going to be a third one because there's the tilde. There's the second identifier. Here comes the plus now. Or the equals, is what I mean to say. Okay, we'll resolve the operator. It's not a close. We resolve. Alright. During the resolving step, the type we're resolving is bit not. We resolve it on one guy. Operands 2. The result comes out -3. That reminds me. Alright, so now it should be resolving not the tilde, but the bit and, sure. 2 operands this time. 3 and -3. I really gotta switch the leaves to actually being U64, now that I think about it. Or I64, I have to figure out which. So that comes out to 1, which is what I expected, I believe. Use another operator, use another leaf, and then we're done. So we skip ahead. We have now a parenthesis, and then we're adding the equal sign. Good. Grab another constant, so we have a second leaf. What are our leaves looking like? 1 and 0. Now we have a close parenthesis, which is going to force them all to resolve. So how many leaves do we have now? Oh. Well, let's take a look and see what this says. It says incorrect. Why was I expecting 0? Oh, other thing was supposed to be defined as 2, I believe. Other thing. Okay, yep, supposed to be a 2. We're going to switch back to this one. test 2. No, no, still breaking. Now what's the problem? What did we break on? How many tokens are there? There's 7 tokens. So it is a different case. And open constant plus constant equals constant close. Boolean constant. Aha! I didn't handle Boolean constants yet. Okay. Integer constant. Boom. Token dot type equals Boolean constant. Well, in this case, all I need to see is the character that we start with. B equals grab this, definitions, files, data, square brackety, token start. If B, no, that result equals B equals P. What? Result, oh no, right, okay, value. Perfect. We're getting pretty far. Okay, operand count. Okay, which one are we at now? What's the token count? Why don't I just put this here so I always see it when we get here? Count is still 7. Open constant plus, but still Boolean constant. We did not resolve this after all. All right. Boolean constant. Break if we hit you. Okay. Oh, duh! I have to set parse type still. Okay. Line 1, 2, 3, 4. Okay, we're back to 0 operators. So, which one is this? We get 10 on the count, and those 10 are open, defined, open, constant, close, and constant equals constant close. Was it defined? Was it and? We'll see soon enough. Alright, so I'm looking for one with a defined. This one. Pop this into easy debug. And test file. Easy debug. Okay, so I want to put a breakpoint here. Let's start from the beginning. First token, parenthesis open, not a problem. Second token, defined. What happens there? Aha! It was not labeled as an operator. Alright, let's see. The, token, right, so it's not labeling it as an operator. That'll be in the parser file where the lexer is written. Boom. Defined. Result.token.flags. CVPT flag operator is operator. There we go. Defined. Canucles, yeah, the fan does have the added benefit of letting you know whether the stream's live. Did it go out, or you just did you question when I froze and thought a moment ago? Was I really that still? Got an operator. Alright, that looks better. Still broke at some point with value of 0. Okay, so we're not out of the woods yet. Not the first time, not the second time. What's on the third time? Parenthesis open, works. Next, constant, fine. Parenthesis close, what happens? Excuse me. It's fine. Let's see. Token add. I got an ad? How did I get an ad? I thought I wasn't supposed to get ads. Apparently I can get ads. Okay, so 1144 is an ad. Wrong file. Lex test. 1144. I want to open the file to meet the line. There we go. Add is another possibility. Close. Add. Still breaking, huh? How is that? How is that? 1, 2, 3, 4. Close. Token add. Flags. Okay, it's an expression operator. You looked at the type, which was CPP token add, and you didn't go to this. 66, 79, and not add. Okay, so add is impossible. It's and that's not impossible. Okay, I thought that makes more sense to me. Do I not have and in here anywhere, actually? I just sort of don't have and written. That's what's going on? Yeah, that's it. Okay. Super. Token and break value equals pp op and. There we go. Let's see if it goes over. Incorrect. Alright. Let's find out why. So for that, I actually want to break on these. Where is this going to break? I don't care about that. Where's my resolve operator situation? Resolve operator situation. There we go. Break here. So what do we have for leaves and operators right now? We have an open and a define sitting around. And for leaves, we have 2. Okay. And it should be resolving that defined now, which means it's going to come up with the answer is 0. Well, of course it's incorrect. I'm not doing it correctly. Okay. So I'm skipping out on defined for now. Alrighty, let's see. I'm going to switch back to test 2. And we're not going to pass everything because a lot of them are involving defined. But let's see if we can get to the end. Ah, we got to the end. 1, 2, 3, 4, 5, 6, 7, 8, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Alright, we got 17 incorrects out of 25. All the ones that involve a defined would cause that. Let's walk through them though and see if some of these can't be resolved. So, correct test part piece 1. the first one. The first one after 0. If other thing, if 3 plus 2 equals 5. Yeah, that should work. Let's put a breakpoint that'll stop right as I'm about to do parsing. So I can skip the first one because it works. Right, so that means I've done I don't really want to be inside the for loop if you're not understanding. Okay. Okay. Just handling a bunch of elifs right now. That's why it's actually doing a lot of work. Alright, there's the correct 0 I was looking for. Alright, so I'm about to parse this one. We're looking for parent constant plus constant equals constant parent on the token stack. There are 7 tokens. Parent constant plus constant equals constant parent. Perfect. Open. Okay. No problem yet. Just an open parenthesis. Identifier, no. Integer constant, yes. Value 3, good. So now we have a leaf of 3 plus. It's an operator. We get op-add, good. Value is not 0. It's not a closed parenthesis. There's not someone else to resolve, and so he gets pushed onto the stack. Good. Alright, what's this next one? Should be integer constant. Should be a 2. We got a 3 again. Okay. So okay, now we're where I want to be. Open parenthesis, integer constant, plus integer constant. Shouldn't be defined as a 3, should it? Define other thing 2. Oh, you know what I gotta do? Duh, I have to undef. But I'm gonna add it to do. Make replace old meaning and give word if already defined. Alright. Other thing is now at 2. Stop that. Rebuild. Run it again. Take off everybody but you. Go to the end. Now we got some more corrects. 1, 2, 3 incorrects there. Those are my 3 defines, and it looks like everyone else is A-OK. So that's it. That's parsing. I don't know how many people we have still hanging out. Some people had to come and go as we went, but if there's any questions people would like to direct at me before I go, now's a good time, because I got the parser going and pretty much got the math part finished. Alright, that's not a problem. I don't need to answer questions. It looks like most people here are oh, you're looking at this? This is not a typo. That's a list of people's names who I just randomly picked friends I know to put in the hash table test. And that is how it's spelled for my friend. Thanks guys for coming. Hope you had some fun watching me work out the basics of a expression parser interpreter thingy. I had fun, and see you guys around. Bye.